Let's take a look at geometric mean in this seminar. First thing, do the first 5 questions. We'll either go them in class or use them as a warm-up for what we're going to be doing today in this lesson. In this lesson, we're going to use similarity criteria for triangles and geometric means to solve problems, improve relations in geometric shapes. First, a geometric mean. When you have a proportion, and we usually cross multiply, well, those things that cross multiply, they have names. The first numerator and the second denominator are called extremes. You can see that when we read it with a colon, they go on the outside. And then, so my first denominator and my second numerator, they are called your means. So a lot of times we'll say the product of the means equals the product of the extremes. That's cross multiplying. Now, if the means are the same, we call that a mean proportional. So when I do the product of the means, x times x is x squared, or a times b. Or a lot of times we'll say x is the square root of a times b. My geometric mean, I multiply and I take the square root. If I would have had 3 numbers, I'd multiply 3 numbers and take the cube root. 4 numbers, I do multiply them together and take the fourth root. That's a little bit different than arithmetic mean. That's your average. So arithmetic, we add and divide by how many are. When it comes to geometric, we multiply and take the root of how many are. As you move into advanced math, you'll see that. Geometric means we multiply. Arithmetic means we add. Now you had this question as a bonus on your Chapter 8 quiz. And so the same thing shows up here. If I have a right triangle, that's got to be a key, that's a key one. You got to have the right triangle. And then if I draw the altitude to my right triangle, it splits that triangle into 3 similar triangles. Now I have to do a little rotating and reflecting to see them. But as it turns out, triangle ABC is similar to triangle ACD, and that's similar to triangle CBD. We get our geometric means here. Notice if I compare my second and third triangles, Y is to H as H is to X. And that's what our first theorem is here. We can do kind of a shortcut. That is, when I have the altitude of my triangle, that's the geometric mean between the parts of the hypotenuse. When I look at the leg of my triangle, I'll use A for example, that's the geometric mean between the entire length and the part of the hypotenuse that touches A. So between C and A, or CY I should say. So A is the square root of YC, B is the square root of XC. And that's how we'll approach it. Now in our first example, I want to find the geometric mean between 5 and 45. So in other words, X equals the square root of AB. In this case, A is 5, B is 45. So X equals the square root of 5 times 45. Well, if I take 5 times 45, notice that is 225. And if I take the square root of 225, X is 15. We're in geometry, so we don't worry about the negatives. It's just 15. It's not plus or minus 15. Now, if we apply that on our next one, using the same thing we just learned on the previous page, I'm going to take these 3 triangles. I'm going to write them out so they look the same. So I'm going to say, here's my big triangle. I've got a medium-sized right triangle. And I've got a smaller right triangle. Notice in my big triangle, my right angle is at S. And my two smaller triangles, they're both at T, aren't they? Now, in my big triangle, I've got angles Q and R. I don't care where you write them. Q and R. So I'll put, what I think I'll do is I'll put one arc on R and two arcs on Q just to show that. Now, in my medium-sized triangle, notice Q is in the same part of the diagram, isn't it? So in other words, Q goes right here, where the same place Q is in the big triangle. While in my medium triangle, the angle that isn't a right angle, that's S. You can see that right here. Now, if I look at my smaller triangle, remember we said I should write in my right angles there. My right angle is T, and in this case, R is in the same spot, so I'll put R up top because it's got to be in the same spot it was in the big triangle. And then I got T, R, and the one that isn't my right angle is S. Oh. So now that I got that, I can write the similarity ratios. So I'm going to say triangle RSQ is similar. If I go, notice what I did. I went R to S to Q. So that means my next one is going to be triangle STQ. And my third one is triangle RTS. They're all similar by angle, and that's what we'll do. Now if we take a look at our next example, in our next example, we've got the altitude drawn to the side of my hypotenuse, so I've got three similar triangles. From my first theorem, I know Z, that's my geometric mean, so I'm going to say Z equals the square root, and I'll multiply my two parts together. 8 times 25. And then since I have 8 times 25, I'm just going to multiply that together, and that's 200. So I get the square root of 200. We're going to write the exact answer here, not a decimal. So now we get to some practice with making some factor trees. So what goes into 200? Well, 100 times 2. The square root of 100 is 10, so I get 10 square roots of 2. And there's more than one way to make this factor tree, but I chose to do it this way. Now let's turn around and let's find x. Now when you find in the leg, you got to know the whole hypotenuse. So my whole hypotenuse is 25 plus 8, that's 33. So if I want to find x, I'm going to say that's going to be my geometric mean. I'll switch colors here so we can see the difference just in case. So x is the geometric mean, square root in other words, between the whole hypotenuse, which is 33, and the part of the hypotenuse that touches x, in this case that's 8. So I'll go 33 times 8. Well, 33 times 8, that is the square root of 264. And then let's make a factor tree for that. Well, I notice 4 goes into 264 66 times. So the square root of 4 is 2. square root of 66. And there's my answer. And then we'll do the same thing for y. The only thing that's different when we do y, whoops, need my marker there. When I do y, I'm going to do 33, but this time it's times 25, isn't it? So if I take 33 times 25, I'll get the square root of 825. And look at that. 25 goes into 825 33 times. I probably could have just split that up right away. So I get 5 square roots of 33 as the exact answer. Now, if you're not told to, you can write those as decimals, but if they say exact answers, that's what I want to see on your assignment and on your test and quiz.